In August 1914, the British Imperial Trans-Antarctic Expedition left England on a ship named Endurance. Their leader was Ernest Shackleton, and their goal was to cross the Antarctic continent and set up a base on the Weddell seacoast. By December, the crew of 27 men and 69 dogs, and a tomcat, had reached the island of South Georgia. They were sailing through the pack ice, but on January 18th, a fierce gale pressed it to the land, trapping the Endurance with no way to go back or forward. They decided to set up camp and huddle together, waiting for the cold to thaw. The ice was slowly taking them away with every passing day. Shackleton kept it cool in front of the crew, but he knew they couldn't go like this forever. As the ice swallowed their ship like a hungry monster, the crew salvaged whatever they could, tossing overboard anything that weighed them down. Books, clothes, tools, they even had to bid farewell to their keepsakes. At first, they thought they could strut their way to safety, but their plans got snowed under when they barely made it 7.5 miles in 7 days. Shackleton decided to camp out and try their luck again when the weather was less moody. Finally, a glimmer of hope appeared on the horizon. On April 7, 1916, the crew saw the majestic snow-capped peaks of Clarence and Elephant Islands. The ice opened, and they knew it was time to boat. But the ocean wasn't any friendlier. It threw freezing water in their faces and played with the boat like a beach ball. They were completely exhausted, but kept rowing until they reached Elephant Islands 6 days later. It was the first time in 497 days that they set foot on dry land. But their troubles were far from over. The chances of anyone stumbling upon them out there were as slim as a needle in a haystack. So Shackleton and 5 other crew members got in a lifeboat named James Caird and set sail on a mission to find help 800 miles away. For 16 days, they were struggling to get through the waves and winds. Just when they thought they had made it to safety, they landed on the wrong side of the island. 3 crew members geared up and climbed mountains, slid down glaciers, and followed a path no human had ever dared to tread before. Finally, after 36 grueling hours of hiking, they arrived at the whaling station, Stromness Bay. How they survived this journey remains a mystery. Shackleton answered this question in his journal entry, saying that he felt like it had been 4, not 3 of them, on that perilous hike. It felt like there had been some sort of guardian spirit watching over them and helping them overcome all the hardships. Famous American English poet T.S. Eliot dedicated a poem, The Wasteland, to that apparition of a person later. But was it really some spirit or a misfiring of their brains, which were super stressed and tired after what they had been through? Now, psychologists use the third man syndrome or third man factor term to describe a situation in which an unseen presence gives comfort or support during traumatic experiences. John Geiger spent 5 years collecting tons of stories of people helped by an unseen spirit and published a book called The Third Man Factor: Surviving the Impossible. Adventurers, sailors, pilots, they all shared comparable stories of how a mysterious presence had saved their lives when they needed it the most. The author mentioned there could be several explanations for this phenomenon. Scientists managed to recreate the sensation of a companion standing beside a lonely person in controlled lab environments through neural stimulation, but it didn't give the same feeling of an active and intelligent presence as real-life encounters. Geiger suggests that the third man syndrome could be a coping mechanism. Our minds make up a comforting companion to help us endure some hard circumstances. Or perhaps there could be a switch in the brain that activates at pivotal points during our life. For Geiger himself, authoring the book became a way to cope with the loss of his son. In the solitude of his study, the author experienced an inexplicable sensation. Someone else was present. The book sparked interest in the syndrome and inspired some further books and movies. The most famous of them is Gravity. And we can all agree that when Tom Hanks was a castaway, the volleyball he named Wilson offered him company and support. Real life also has some pretty impressive stories, like that of Frank Smith, a fearless explorer who almost reached the mighty peak of Mount Everest. As the conditions worsened, one by one, Frank's hiking group gave in because of snow, wind, ice, and low oxygen levels. But Frank pressed on, pushing his limits. He was just a mere 1,000 feet from the summit when reality came crashing down and he had to accept defeat, descending back down the mountain. On his way down, the climber pulled out a mint cake from his pocket and instinctively held it out for his hiking buddy. Only there was no one there. He had been hiking solo for hours. Frank confessed that throughout his lonely climb, he felt an uncanny presence, like a mysterious hiker by his side. It was so real that he felt no loneliness at all. James Savigny, then a 28-year-old mountaineer, was climbing in an isolated part of the Canadian Rocky Mountains. Suddenly, an epic roar echoed through the mountains. It was an avalanche coming. And just like that, he was airborne, hurled 2,000 feet below in a snowy whirlwind. When James regained consciousness, he thought he wouldn't make it out of the snow alive because of the many injuries he had. But then, out of nowhere, the mountaineer felt a mysterious presence right behind him and heard a voice urging him, "No, you can't give up. You have to live." Nobody knows where that voice came from. It was like a whisper in the wind, but it was as real as it gets. Savigny didn't believe in spirits and the like, didn't have an explanation for what had happened to him. He later remembered it sounded like a female voice, warm and nurturing. It gave him clear instructions to put on the jacket, to get water. James didn't question the commands, he just followed them. The voice led him through the valley into his campsite. There, he saw 3 people skiing and asked for help. At that very moment, the voice had left him. It turned out one of the people he had run into was a mountain guide. Another was an elite cross-country skier, and the final person was a nurse. There couldn't have been a better combo to help him. 2 years after the incident, Savigny couldn't talk about it without crying. He was positive that he wouldn't have made it out alive but for the voice. When you have to deal with an extreme environment and struggle for your life, your brain takes center stage as the ultimate survival superstar. It turns into a treasure trove of outdoor know-how, from rubbing sticks to start a fire to crafting a cozy snow shelter. It's got all the handy skills stored up. Intuition and judgment join in to guide your life-saving decisions. Even fear can be useful in such situations. There's a tiny region in the brain called the amygdala, our emotional hotspot. Whenever it spots something that stands out, like a human face showing emotion, it kicks into high gear. Imagine you're face-to-face with a predator, like a lion on the prowl. Your amygdala activates all the necessary functions, and before you know it, your body's in full alert mode. Pupils dilate, bronchi open up, breathing races, heart pumps like crazy, and blood pressure spikes. The hippocampus and prefrontal cortex work behind the scenes to analyze the situation and decide if it's a real danger or just a friendly zoo lion. They process all the context and calm down our amygdala's fear response. When the risk is real, fear gets your full attention on the situation. It becomes your own personal Zen master, guiding you into the here and now. All those distractions fade away, and you're fully tuned in to the present moment.
Your kitchen sink is filled with dirty water. You've just washed the dishes, and you pull the plug out of the drain hole. Do you see how the water forms a funnel, and all the pieces of food get into its center? This is a small whirlpool. Now imagine that this is not a kitchen sink, but a sea with a several feet wide whirlpool. And it draws in not pieces of food, but a small boat. And you're on this boat. You jump off the side and try to swim away. But the whirlpool is stronger than you. It attracts you despite your attempts to swim away. So the first thing you should do is calm down. Yeah, it isn't easy when the deep sea is trying to swallow you up. But if you don't save your strength, you won't be able to survive. And now remember one life hack. Do not try to swim in the opposite direction when the current from the shore carries you away. Head to the side. Thus, you escape from the stream sooner or later and can safely swim to the beach. Inside the whirlpool, you have to act similarly. you need to stop struggle and swim in the direction of the flow. Thus, you'll keep your energy and increase your speed. But don't swim at the very center of the vortex. Try to move away from it in the last moment and you'll get out. Now go to the surface and stay away from the whirlpool. Great! You have survived. You promise yourself never to go to sea again without a life jacket. But of course, the best way to escape from the whirlpool is not to get caught. If you're going on a sea cruise or kayaking at the mouth of the river, find out all about these places. Perhaps they are filled with water traps. You swim to the shore and decide to learn all about whirlpools. It forms in the sink or bathtub because the water begins to drain into the hole and swirl. There are no drain holes in the sea, lake, river, or ocean, and water is formed there because of the collision of two currents. A strong wind can only create one current. The difference in water temperature and its density can make another. Also, the current can be caused by tides. This is when the moon's gravity affects the water. So when two currents flowing in different directions meet, they form a vortex. Two streams of water swirl around each other and move down in a spiral, creating an empty space in the center. Most of the whirlpools are too small and don't pose a danger. But if the water vortex is strong and large, it can sink ships. Such strong whirlpools are called maelstroms. They are usually formed when two currents collide near narrow reservoirs and straits. The world's largest and most dangerous maelstrom is located in the Saltstraumen Strait in northern Norway. Every 6 hours, a whirlpool forms there with a diameter of about 33 feet wide and 16 feet deep. And it can be several whirlpools formed at once. Ships sailing through the bay follow a strict schedule to avoid falling into the water trap. This whirlpool got into the Guinness Book of Records as the largest in the world. However, some whirlpools are hundreds of times bigger, but they are invisible. Giant whirlpools in the Arctic Ocean can reach 18 miles in length. This is the size of a city, and these giant whirlpools are invisible. Fortunately, they are not as dangerous as those that form in Norway. The waters of the Arctic and Atlantic Oceans mix and form water vortexes invisible to satellites. Usually scientists notice such whirlpools with the help of thermal imagers or a change in the color of the water. When the current filled with marine life mixes with lifeless waters, it is visible from the satellite. But the new giant whirlpools are masked under a layer of water with the same temperature. They hide deep enough not to be noticed by satellite thermal imagers. Scientists manage to catch them using gliders. These small pilotless submarines float underwater and record information about the temperature and salt level. Scientists discovered that these whirlpools formed because of the collision of cold and warm currents. Warm water here is rich in nutrients, while cold water is almost lifeless. In this way, warm currents share useful elements and spread them evenly throughout this region of the ocean. Observing invisible whirlpools can help scientists uncover many details about the structure of ocean ecosystems. Whirlpools exist not only in water but also in space. Vortexes from the plasma energy of the sun can be several times wider than the radius of our planet. However, all this solar radiation cannot create giant vortexes on Earth because the magnetic field protects us. The solar wind glides past the planet's atmosphere like a wind over the ocean's surface. But a little energy still manages to break through the protection. Solar whirlpools insert an electrified gas into the magnetic field, creating holes through which the sun's plasma passes through the atmosphere. If whirlpools happen during the collision of different currents, it means that you can predict their appearance in advance. But there are unpredictable natural phenomena in the seas and oceans that pose a danger for small boats, yachts, giant ships, and oil rigs. The phenomenon is called a rogue wave. So now let's get aboard your yacht and sail somewhere in the ocean. It doesn't matter what ocean and where exactly you are, because rogue waves can appear anywhere. A small storm is starting, but your boat can easily handle it. The wind raises small waves that beat against the hull of your yacht. But then, among these waves, one giant appears several times larger than all the others. It would quickly turn your vessel over like a paper ship. But fortunately, this wave passes by and dissolves into the sea, This unpredictable wave of enormous power can destroy huge ships in a second, and such disasters have happened many times. Sailors all over the world told each other stories about the giant waves that appear during a storm and in a quiet sea. Many considered such waves only fairy tales, such as legends about the Kraken and Atlantis. But at the end of the 20th century, people were able to capture this sea phenomenon with a laser detector that measured the size of the wave. On January 1st, 1995, a massive rogue wave crashed into an oil station in the Norwegian North Sea. There was a storm that day, with big waves about 40 feet long. At some point, they formed a big guy, an 85-foot wave. That day, rogue waves turned from a fairy tale into reality. Researchers estimated that this natural phenomenon may destroyed about 22 supercarriers only in the second half of the 20th century. Also, scientists discovered that just 1 in 10,000 waves is a rogue one, and every year, their height increases by 1%. Some of the largest rogue waves reached a height of 100 feet. It's like a 10-story building. This giant can easily break even the strongest and largest ship. Scientists can't always predict their appearance, and still don't know their nature. So rogue waves make the ocean a much more dangerous place than we thought. According to one version, rogue waves appear because strong winds create big waves. When two such waves collide with each other, a giant rogue wave may appear. Another theory says that eddies create rogue waves. These eddies form along the edges of the ocean currents, and then they drift separately for a long time, increasing kinetic energy and forming eddies field. The kinetic energy contained in these fields can charge the waves and increase their strength. However, scientists study microwaves and light to understand this phenomenon better. It turned out that these sea waves are similar in their behavior to these two natural things. The researchers hope studying light waves will help understand the nature of rogue waves.
Now first, you probably already know that germs are everywhere, and it's impossible for humans to get rid of them. These tiny creatures train our immune system. We're becoming stronger when our organism constantly faces bacteria and improves its protection skills. So don't worry about what you see next. Welcome to one of the favored places among bacteria and microbes, hotel rooms. Yes, they seem to be so clean, but in some ways, they're more dangerous than a garbage dump. Everything is dirty at the landfill, and you're afraid to touch anything. But the dirt in hotel rooms is almost invisible. Germs are waiting for you here, and there are a lot of them. So the first problems appear already in the elevator. The buttons on the panel are swarming with various bacteria. Suppose no one cleans them with a disinfectant. In that case, these buttons become the arena where billions of microbes multiply and devour each other. Take a look at an ordinary apartment building. There are elevators too. The same people live in this house, transmitting the same germs when they touch the elevator buttons. Your body encounters these microbes often and quickly develops the needed protection. But different people stay in hotels. A guy from some African country can bring a bacterium that will be dangerous for a girl from cold Norway. Therefore, after you touch the button, wash your hands with a soap or disinfectant. So, the elevator opens its doors and you walk towards your room. Watch out! There's another hot spot ahead. See that door handle? This area is another beloved playground for germs. How many people have touched it before you? How long has it been since it was washed? Do you know why such a handle is more dangerous than a toilet seat? Most of all, microbes accumulate on our fingers and palms. When we don't wash them, we transfer 1 million bacteria from one place to another by touching the surfaces of different objects. So the best way is to touch the door handle with the same hand you use to press the button in the elevator. As soon as you enter the room, wash your hands. The good news is that hotel staff clean bathrooms and toilets much better than the rest of the room. So you're a bit safer here. But still, take a good look at the corners of the bathroom and the tiles. If you see black spots somewhere, it means there's mold. This thing can cause allergic reactions like runny nose and eye irritation. Mold can be pretty dangerous, but hotel staff usually watch it closely. So it's unlikely that there will be something like this in your room unless it's a cheap hotel. You don't stay there, do you? Oh, by the way, did you know that toilet paper in a public toilet contains more germs than the toilet lid? You make a mistake if you cover the seat with pieces of that paper. First, many people touch it, which means they transfer bacteria onto it. Secondly, dirty little splashes get on the roll when someone flushes the toilet. Microbes feel more comfortable living on soft paper than on the hard surfaces of the toilet, so don't put it on the seat. But if you see a metal or plastic cover on the roll, you're lucky, since the roll is protected from germs. Then, after you've done your business and washed your hands thoroughly, you have two options. Wipe your hands with a paper towel or use a hand dryer. It doesn't matter which you choose, both variants have a lot of germs. But if you use the dryer, bacteria will fly all over the room, so better grab a towel. Okay, you come out of the bathroom and find yourself in a danger zone. Don't think that all germs there are harmless. Some of the most common bacteria in hotels cause intestinal infections. If you don't want to spend the rest of your vacation or business trip next to or on the toilet, get ready to fight colonies of tiny parasites. The first thing you need to do is wash those glasses and cups with soap. Some travelers carry their own mugs with them, which is a good idea. Then look around and ask yourself, which places do people touch the most? These are the TV remote control, coffee machine, fridge, door handles, tables, hairdryer, and windows. But relax, you don't need to do the cleaning instead of the hotel staff. It's enough to have wet wipes with a powerful disinfectant. Wipe the surface of all these objects. Perhaps you worry in vain, and the hotel carefully monitors how clean the rooms are. Or you can tell the manager you want to have your room cleaned again. So you've wiped all the surfaces and jumped into bed tired. Unfortunately, you're not the only one to rest on that soft mattress. You have a huge company of bacteria. Of course, washing pillowcases and bed linen destroys germs, but what about the bedspread? Most likely, nobody washes it. Removing germs from the tissue is difficult, so you'll probably have to put up with it. But the thing you shouldn't accept is bed bugs. If you notice dark spots on your mattress, this is most likely the waste left by bed bugs. You're not hungry, are you? I don't want to spoil your appetite. The insects themselves can hide deep in the mattress. They can sleep there for months and then wake up to satisfy their hunger. While you're resting, they come out and bite your legs. If you notice small red spots on your skin in the morning, then bed bugs have, kissed you. The bites of these beetles are not dangerous. Some people may have a mild allergic reaction in the form of irritation on the skin. But the problem is that some bed bugs can get into your clothes or things. Then you'll bring them home. These creatures multiply rapidly. Therefore, if you don't want a colony of biting bugs in your house, then wash your clothes, clean your luggage, and go to the shower. But before that, ask the hotel manager to refund your money, because bed bugs are By the way, even if the room is squeaky clean, it doesn't mean there are no bed bugs in it. Perhaps previous guests brought them. So your bed has no black spots, and you have wiped all the dangerous surfaces. That's it, you're safe. But try to walk on the floor wearing slippers or thick socks, as the floor is also a source of dirt. You spend several nights in the hotel, and finally return to a clean and safe place, your home. Unfortunately, your house can also have many germs you don't see. Do you like to have fun with friends and play video games? Do you remember when the last time you cleaned the gamepad was? All your friends have held it in their hands, which means you've collected all of their microbes there. Your kitchen cutting board. How thoroughly do you wash it? It's not enough just to splash it with water, especially if you cut meat and vegetables. You can cut some squash, and its germs will stick to the surface. Then you quickly wash the board and put it back in place. But the germs haven't gone away. They're still firmly attached to the surface, waiting for you to cut bread. Then they'll jump onto the food and get into your stomach. How's that appetite doing? Still good? Another dangerous place is a dish sponge. Even if you use a good detergent, germs still accumulate there. The best way to get rid of them is to change sponges once a week. And now you'll see a paradise for bacteria. a place with an ideal cold temperature and a lot of food, from fresh to spoiled. Hey, it's your fridge. There you put products that you bring from the supermarket. Hundreds of people could touch them with their hands, leaving millions of germs. Therefore, don't forget to wash your fridge often. And also, keep any meat away from packaged products, because germs on a rare steak multiply and spoil it quickly. Well, perhaps you're too worried about your health now. If so, then you should remember the words from the beginning of the video. Let me quote. You probably already know that Germans are everywhere. Wait, that's not it. Sorry.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brrr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone.
Let's cut the Earth in half.
You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal, and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the sun. We think of the sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air, so all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about negative 140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.